This is surface area of rectangular prisms. All right, so surface area is the total area of all the faces of a 3D figure. So the total surface area, think about the surface area of this. The surface is everything on the outside. So if I wanted the surface area, I want the area of everything on the outside. Okay? So to find surface area, we find the area of each face. So on a 3D object, we call a side a face. So like this is a face, this is a face. Okay, so this, or this one right here, this rectangular prism would have 1, 2, 3, 4, 5, 6 faces, or 1, 2, 3, 4, 5, 6 faces. Okay, after you find the area of each face or side, we add them all together. We can use nets to help us determine the surface area. A net is a 2D representation of a 3D shape. So this 3D shape right here, a net, essentially what it does is like if you cut the edges of it so that you could lay it out flat, this is what it would look like. So if I made some cuts here and there, so that, think of a cereal box. If you cut some edges of a cereal box, you can lay it out flat. Okay? So this is called a net. That's a net. Nets are really helpful when you're trying to find surface area. It really lays it out for you. Nets are not always given though, so I mean, if they're there, use them. If not, you're just going to have to be able to visualize it. All right, so lateral surface area is the area of just the sides of a 3D figure. So for instance, like this guy over here, your lats are the muscles that are down the side of your body. So these are where your lats are, those muscles right there. So you could think of it that way. If I ask for the lateral surface area, it's the area of just the sides of a shape. It does not include the bases. Okay, so no bases when you're finding the lateral surface area. If that's a hard way for you to remember in football, something like that, if you make a lateral play, it goes to the side. You could think of it that way. To find the lateral surface area, we find the area of just the sides, and then we add those together. I always start with lateral surface area, because if I find that, I know I've at least answered one question, and then to find the total surface area, it's a lot easier just to add two things to it. All right, so let's find the area of each face. Okay, so this is kind of hard to visualize. But if this side is 4, this side's 5, think of a rectangle. That means this side's 5 and this side's also 4. If you were to fold those two pieces up, like you're trying to put a box together, these two sides would meet and they'd have to be the same length. Okay, so that means this side is a 4 also. If this side is 4, that means this side is 4. Same thing here. If this side is 3, that means this side's 3, which also means this side of this rectangle is 3. So this side is also 3. If this side's 5, then that side's 5, then this side's 5. That means this is also 5, and this is also 5. Now we're coming down the edges here. If these two sides were to fold up and meet together, like you're putting a box together, these two lengths would have to be the same. So that's 4. Same thing here, 4. And since these have to be the same, that means this side is 4 and that side's 4. So there's just one way to kind of figure out the different side lengths. Okay, so if I have a net, I always like to use a net because it's easier. So let's find the area of this face right here. We're going to call this one A. Okay, to find the area of this, it would be 4 times 5, which is 20. Okay, let's find the area of this one. Let's call that one B. That's that's going to be 4 times 3, which is 12. Okay, and then the area of this one right here should be the same thing. 4, we'll call that one C, sorry, 4 times 3, which is 12. Okay, and then I messed up on one of these. This one right here. Sorry, it's supposed to be 3. When you wrap this all back around, these two ends will meet together. So that means that this is going to be opposite of this one. This is hard to picture. But that means that's going to be 3 also. All right, let's look at this guy. Okay, we're going to call you D. I probably should have made that. Sorry. I'm going to make it yellow. I'm so sorry. Okay, the reason I'm making it yellow is because A and D are opposite one another. If you fold those two sides up, they're going to be the same thing. So that's also going to be 4 times 5, which is 20. And this bottom piece is 5 times 3. That's 15. We'll call that one E. And then right here, we'll call this one F. Again, that's going to be 5 times 3, which is 15. Remember, when you think of like a box, sides are opposite one another. Sorry, this side and this side are opposite, but it's the same side, so, or same size. So that's why I made these colors, and these are yellows and those are greens. Okay? Because these are opposite one another. You can't have something that's on opposite sides and touch. You can't be opposite and neighbors at the same time. So, all right. So to find the lateral surface area, that's the area of all the sides. Well, first off, let's figure out which one of these is the base. So if you're looking over here at this picture, the base is what it sits on. So that's this rectangle down here, which is 5 times 3, which is 15. So it looks like these two are my bases, because that would be this one up here also, which would also be 5 times 3. Okay, so those two are my bases. So E and F are my bases. My blue ones over here are my bases. So if I wanted to find just the lateral surface area, when I'm adding up these areas, I'm not going to include these. Okay, so I'm just going to add up the areas of the other 4 sides. So 20 plus 12 plus 12 plus 20. That would be 4. And this would be 6. Okay, so we're adding A, B, C, and D. All right, so the lateral surface area would be 64. Say lateral surface area is 64 centimeters squared. Area is always squared. The total surface area would be the lateral plus the bases. So I'm going to take that 64. And I'm going to add the 2 bases, so 15 and 15. So that would be 10, 14, that would be 7, 8, 9. So the total surface area would be 94 centimeters squared. Okay? So remember, lateral is just the sides. Total is the sides plus the bases. It's everything. So let's look at these. Let's find the lateral and total surface areas of both figures below. So what I always like to do is I like to go in and highlight my bases. That way I know what the bases are. So this bottom one is a base, and then the top one, which would essentially make me color the whole thing, is also a base. So let's see. If you think about it, like we said up here, every side has a partner. So in a rectangular prism, there's top and bottom, these sides, and these sides. So essentially I can find the area of one of them and just multiply it by 2 because it's the same thing. All right, so let's find the area of the bases. This rectangle down here is a 4 by 7. So 4 times 7 is 28. but because I have a top and a bottom, my bases, I could take that and, I could write it twice, and then add it together, and you get 56. Okay, now let's find the area of the sides. So for the sides, I'm looking at this one, let's do the left and right sides. So these rectangles right here. So the height of this rectangle is 5, and the base is 7. So I'm going to do 5 times 7, that's 35. And I know I have one identical to it on the other side. So another 5 times 7 is 35. Okay, if I add those two together, that's 70. Okay, so I know my side to sides are 70. Now let's do the front and the back. Okay, so that would be a 4 by 5. The height is 5. So 4 times 5 is 20. And I have two of those. They're identical. So another 20, which is 40. So these are, and we'll call that side 1, this side 2, or I guess sides 1 and 2, and then sides 3 and 4. So if I wanted the lateral surface area, that would be just the surface area of the side. So I would add those together. 70 plus 40 is 110 inches squared. If I wanted the total surface area, I would add all three of these totals together. So 70 plus 40 plus 56. When I add that, that's 110, and 110 plus 56 is 166 inches squared. Let's try another one. Now number 2. So let's highlight the bases, or debase, bottom. And for every bottom, there's a top. So I know I'm going to have two of those, the exact same size. So the bases, the area of this base, well, that's a 10 by 5. So 10 times 5 is 50. And I know I have another one of those on the top up here. So that's another 50, okay, for a total of 100. So I know the bases equal 100. Now let's do the sides. So let's say sides 1 and 2, just like we did on the other one. Well, let's do these ends right here. Okay, this end and this end. Let's do those two ends. So this end over here, it's going to be 2 times 5. So 2 times 5 is 10, and then I have another 2 times 5, which is 10. Identical sides. That's 20. Then I have sides 3 and 4. Okay, that's going to be the front up here. So I'll do it in a different color. It's going to be this rectangle up front, and then the one in the back here. So it's like the front and the back. So we have top, bottom, side, side, front, back. Okay, this rectangle has a height of 2 and a width of 10. So that's 2 times 10, which is 20. And then I have one on the back also, so another 2 times 10, which is 20, for a total of 40. So if I want the lateral surface area, it's the area of the sides put together. So that's 20 plus 40, which is 60 centimeters squared, because we're using centimeters. If I want the total surface area, it's the sides, 20 plus 40, plus the bases, 100. So this is 60, and 60 plus 100 is 160 centimeters squared. So that's how you find lateral and total surface area.